Hello everybody, today we are going to train pointers. Today we are going to see how useful pointers are. Okay, so we will start this lesson from example like that. When I have a variable, for example int a, and I will assign to that variable value 10, and I want to change value under the address here, so in this variable, in another function, I have to use the reference or pointers. Let's remind the version with the reference. I had to do something like void multiply by, then what are arguments in our function. So the first argument is the reference, and the second argument is by what amount we want to multiply by. Then, after creating the prototype of function, so after declaration of function, we should create a definition of function, so the body of it. And now, here we have the variable that we want to multiply by something, and here is the amount that we want to multiply by that guy. Because this is a reference, it looks like the definition and initialization looks like that, equals here the 8, and now the var is just the nickname for a, right? And because of that, now when I, for example, do something like that, I am changing the value also here, right? So now when I send to the output a, after of course changing it by that function here, for example, let's multiply 10 by 5, we should see here as a result, oops, of course, a, we should see as a result 15. Okay, everything works fine. What about if I wanted to do that thing by using the pointers? It would look like that. Here I am taking the pointer right now. Of course, here I am changing it also. And now I should use here that asterisk, right? Because a pointer is what? Pointer is a variable that can store an address of type that it is pointing to. So that pointer here can store an address of the variable that is integer, right? So right now we are sending the a here. Well, we shouldn't send an a here as a value, because we should send here what? An address, because we want to store an address here. So I'm sending here right now an address of a, right? And here it would look like that, something like that. And now we have an address in that guy, and with the asterisk here we can get the value from that address, right? Well, let's maybe do it that way. It will look a bit easier, right? And now let's see, it's working. As you can see, the value is again 50, so everything works fine. So I'm reminding you that we have to send an address here when we are taking the when we are declaring here as a parameter the pointer, right? Okay, now I'd like to also tell you how to return pointers. Well, if I do something like that, and now I will return here something like that, I am returning only value. So if I do here int b, and then I will send b to the output here, I should have 50 and 50, right? Everything is okay, but this guy here right now is totally different variable. Now when I send here, for example, 999, we will notice that we changed the value of b, but we didn't change the value of a. If I want to return the pointer, I have to add here also an asterisk. Of course, it can be here, it can be here, it can be here. Don't worry, this is just white space, they are not interpreted. But, well, I prefer the notation like that. And now, look, I won't be able to compile it because here we should return what? A pointer. So we are returning a pointer and we are trying to assign it to the guided canster pointers. Right now, when I change it to the asterisk here, I can store it easily. And of course, now we should change the value that way. And we should also return a pointer. So we're not returning a value, but the address, right? And now let's see. As you can see, of course, here like that. As you can see, now I change the value here and also here, okay? So that's how you can return a pointer. Okay, that thing, if we could only do that things with pointers, you wouldn't be happy now because you would be like, hey, I lost lots of time. I could do that things almost with reference, right? Almost everything like that. Yes, but look, right now, because of pointers, we can send to functions arrays. Before we couldn't do that. Because arrays always are in our memory stored that way that they are next to each other, right? And because of pointers, because they are storing address, the first address of first element in an array, we can jump one by one element, right? Because they are next to each other. And we can just send the first guy and then we can jump to the next guy, and I'm sure that this will be my value in an array somewhere, right? Okay, so let's create an array. So int array, and let's make size here 10. Let's assign here 0 at the beginning, or maybe we don't need to do it that way. Let's just assign value to all of the guys here. So let's do something like that. Array of I equals, and let's assign just I here, and let's send to the output so you can see how does it look like right now. And let's compile it. And as you can see, so we have 0, 1, 2 to 9. We can send it that way so it will be easier to read later and debug our program, right? So to check if there are any bugs. As you can see now, everything is working fine, okay? And well, let's create a function that will be able to change, well, it will multiply our array by some kind of value. So multiply by, multiply array by, and here, for example, I will create two parameters, int, and now it will be the pointer here, right? We'll send an array here because name of array, so that guy here, array, is really a pointer, right? So we can send it here like that. And then we have to also send, of course, the amount that we want to multiply that guys by. Oops, I didn't copy that. Now everything is okay. So let's name that guys array, and here I will type amount. Okay. So, well, we want to multiply that, guys. I would like to also add, you can send arrays that way also. That way is okay too. So you can send array that way. Well, let's do that. For example, multiply array by, let's send the array, and then, for example, by 5, right? As you can see, everything is working, and we can do it, of course, that way. So both ways are okay. Okay, and now how to change values. So for example, let's create a loop when I is lower than 10, then I plus plus, and then we should just do array of I equals array of I multiplied by amount, right? And now we can send it to the output. Let's go on that guy here, and we should just see everything multiplied by 5 in that array. So everything works fine. As you can see, now we can send easily arrays to functions. But hey, you might be like, oh, why are you typing the 10 here? Isn't it too easy? Yes, it's really too easy right now, and it is very bad idea to do that way. Because I can change it right now here to, for example, 16. Well, I will have to change here and here that amount. And well, I could do it as a constant. This is a good idea, but it's not still the best idea, because for example, what about situations when we are dynamically creating arrays? Then we should check the size of arrays. For example, how to check the size of that array here. Let's send to the output something like cout size of and then name of array. Let's make a few let's just comment that here, and what we'll see, build an array. As you can see, it's 240. Why is it so? Well, let's make it a bit lower value. For 10 it is 40, because 10 multiplied by 4 is 40. So this function is returning us how many bytes are stored in memory for an array like that. When I do something like size of integer, you'll notice that now here is 4. So this is giving us the size of integer. When I do something like that, it will give us the size of one of element in that array. I think this version is the best, because we might also change this guy to double later, and then here also it will change other things. You have to, of course, change also function, but well, you know what. Okay, so this is really better idea to use something like that here. And now we can, of course, do also something like that. Size of our array divided by the size of type that is right now here will just give us the size of array. So it is 10, right? And now we can just use it. Now we can just change it here, and it will work fine, as you can see. But there is a problem. When I do something like it here, so when I check the size of the pointer, not an array, here is a pointer. Here we have an array that was created by us, and here we can check the size like that way. But here, look what will be what value we will see. It is 4, as you can see, so it's wrong. Because of that, unluckily in C++ we have to send the size of array to the function. So we have to send it here that way. And now, of course, let's change it here. We can, of course, make it that way also. And now, let's see if it's working. Let's change the prototype also. So the declaration of function. And now, as you can see, everything works fine too. Now let's train a bit. So for example, let's change the loop to something like while the size of array minus minus. So until we see here the 0, please execute the instruction below. size of array, amount. Let's see if it's working. As you can see, it works too. Okay, and now how it works? Well, we are sending the size of array here, so 10. So we have in size of array 10, and then here is a post the decrementation, so we are decrementing it after checking the condition. So if 10 it is true, then we are decreasing it to now, and we are changing the value that is under the array of 9, and we are just multiplying it by that amount. So that's how it works, right? Until this guy here is just 0. Okay, I would like to also add now that you should notice that this guy here, right, that array, is being set that way, not that way that we are sending the address here. Because remember, if I did it that way here, I would send the address of a pointer, not the value that is stored in a pointer. I know that the pointer is also storing the address, but it is address of something else, right? It is not address of a pointer, but it is address of something that under it we can find a value, right? For example, like that, okay? A value that is double, that is float, or something like that, for example. Okay, and so it means that we can send here it that way. So we are sending it here the first element. Everything will still works fine, and I'm telling you now that array of 0 equals the name of our array, right? Because it is really a pointer. Okay. That's all in that lesson. Thank you very much.